Hello, and welcome back to my ongoing coverage of the OceanGate Titan submersible tragedy. This video covers the testimony given at the US Coast Guard's public hearing by Mark Negley, a material and process engineer at Boeing. So last time we heard from a representative of NASA, and I'm glad these two testimonies were one after the other, as both NASA and Boeing were company names used in some of OceanGate's promotional material for Titan. In this video, we hear about the interactions Boeing had with OceanGate and the work that was performed, as well as thoughts on safety and best practice. As this is once again a relatively short video as far as these testimonies go, I will save most of what I have to say for the end. So for now, thank you very much for clicking on this video, it is very much appreciated. Now, let's just get started with the testimony given by Mark Negley.
Mr. Negley, we're going to start the line of questioning from Lieutenant Commander Williams.
Good morning, Mr. Negley.
Good morning.
First, thank you for being here with us. If you need a break, please let me know. All of my questions are related to your background and then your experiences with OceanGate. Before we begin, I will ask to please refrain from using any acronyms. If you should use an acronym, I will stop you and ask you to explain what that acronym means. We may be using an exhibit today. If we do, it should show up on your screen. If it doesn't, please let us know.
Yeah.
Can you briefly explain your background and work history before becoming involved with OceanGate?
Certainly. I've got a BS and an MS in engineering from Iowa State University. In 1995, I started working for Boeing. I went back and did some additional grad work, came back to Boeing in 1998, working in the non-destructive evaluation research and development group. In 2003, I went over to the Phantom Works physics research and development area. In 2006, I went to Boeing Research and Technology composite fabrication research and development up until 2019 when I went over to Amazon as the senior hardware design manager for their structure of their drone. And then I returned to Boeing in 2023 and went into a group in Boeing Research Technology called Specialty Materials and Integration.
What was your experience with submersibles prior to working with OceanGate?
Prior to working with OceanGate, internally we've done a number of different small composite pressure vessels, primarily doing work for like the Applied Physics Lab at University of Washington, or for oceanography at the University of Washington. The primary program was the Deep Glider program for the University of Washington Oceanography Department.
And what was your experience working with carbon fiber prior to working with OceanGate?
I have significant experience working with kind of complex structures and the development of manufacturing techniques for producing carbon fiber materials and components.
It is our understanding that Boeing entered into a proprietary information agreement and technical services agreement for a preliminary feasibility study for a concept vessel in 2013 with OceanGate. Can you describe what was asked of Boeing for this preliminary feasibility study?
Yeah, briefly, we had two parts of that feasibility study. The first part was to look at a previously done design and analysis that OceanGate had commissioned from a company called Blue Force. So we evaluated the analysis methodology and the design of that configuration. The second part of that was we were given specific requirements from OceanGate, and we were asked to determine and come up with a feasibility study, or whether it was feasible to have a design with a certain amount of buoyancy and safety factor.
Has Boeing ever built a composite structure of similar size to that of the cylindrical hull referenced in the conceptual feasibility study?
Could you repeat that question again?
Has Boeing ever built a composite structure of similar size to that of the cylindrical hull referenced in the conceptual feasibility study? So for reference, at the time it was going to be potentially 10 inches thick, which then was reduced to 7 inches thick, but we do know now that the hull was 5 inches thick. So has Boeing ever built a composite structure of a thickness between 5 inches and 10 inches?
To my knowledge, the thickest part that we've really built was about 12 inches thick. It was not the same size or configuration of the OceanGate hull. And one of the components that we built was a smaller component that was used as a non-destructive test standard for that 12-inch thick component.
We noted in the feasibility study that the cylindrical hull over time was decreased from 10 inches to 7 inches. As I previously stated, we now know that that final hull was 5 inches thick. Was Boeing involved in any conversations that reduced the thickness of the hull from 7 inches to 5 inches?
There may have been conversations where we were asked about that, but in general, we did a feasibility study, preliminary analysis, and came up with a 7-inch hull that we thought was potentially feasible. Basically a concept or a trade study output. That design utilized unnotched composite allowables and didn't consider, any of like the future detailed design work or effects of defects or anything, that would have been in a detailed configuration and analysis. And so that, our expectation would be not that the hull got thinner, but the hull would have gotten thicker in order to account for some of those potential defects or other considerations in the design.
Can you explain what you meant by unnotched design?
It refers to it refers to an allowable. So you have a kind of a statistically significant data that you've generated based off of a stable and repeatable material using a stable and repeatable process. The statistical significance of the output of that process is used with different types of coupons. Those coupons are used to kind of characterize the capability of the material with different configurations. A common set of coupon styles would be open hole, filled hole, tension and compression, and unnotched, meaning there's no cutout in the specimen that you're testing. It has no holes, it has no defects, it has no notches. And so it's kind of a pristine coupon.
Thank you. One main difference we noted was that the conceptual design included 45-degree plies. One of the statements of the report said, allowable strain tables do not support layups without plies oriented at the 45-degree direction. The final direction was constructed of only circumferential and axial plies, therefore there was no 45-degree plies in that final design of 5 inches thick. Was there any discussions with OceanGate about excluding the 45-degree plies?
Yeah, there certainly would have been. You would need to have the allowables data to support your design and your engineering. The material system and the production method that we had proposed, we did not have any allowables or supporting data for anything that didn't have 45-degree plies in the laminate configuration.
And can you briefly explain the potential importance of including 45-degree plies?
I guess the thought would be that there's potential for increased potential for damage or damage propagation based on the 0-90 configuration without a cross ply, or that the load redistribution, if you had damage, wouldn't be wouldn't be performed as well, or the laminate might not be as robust as it would be if it had 45-degree plies in there.
Did OceanGate provide feedback to Boeing after the study as the design changed to determine if their updated design fell within acceptable limits?
Can you ask that again?
Did OceanGate provide feedback to Boeing after the study as OceanGate's design changed to determine if their updated design fell within the acceptable limits from the feasibility study that was conducted by Boeing?
I don't believe we received any feedback. We really never saw a full-up design or analysis from OceanGate.
We noted that there was discussion regarding non-destructive testing in the conceptual design report, specifically that through transmission ultrasound or pulse echo ultrasounds have been used and were suggested to OceanGate. Do you know the effectiveness of these methods, if it's limited to specific thicknesses?
Your sensitivity would be reduced based on the thickness of the hull, or based on the attenuation and whether or not you're able to penetrate through the hull with a specific frequency. As the material gets thicker, you're most likely going to have to go to a lower frequency, and that's going to give you less detail in the scan. And so your sensitivity and what you're able to detect is going to be diminished. And just to state, the general process would be that you create a standard and then evaluate that standard, for the material, for the thickness of the product you're making.
Were there any additional discussions with OceanGate regarding other non-destructible test options for a thick carbon fiber cylindrical hull after the feasibility study was completed?
There would have been probably discussions about manual ultrasonic scanning through transmission, pulse echo. We would have suggested things like CAT scanning, X-ray. Each of those different types of non-destructive methods would have had specific capability, things you could detect and things that you couldn't.
And in your experience, would any of those been successful through 5-inch thick carbon fiber?
We've demonstrated through transmission inspections through 12 inches of composite.
The conceptual design report suggested validation coupons or building block test components. Can you explain what these are and why they are important?
One, like I said before, you need to have a stable, repeatable process. You need to have statistically significant data characterizing your material, and then you need to run that material through the process of manufacturing. You need to generate your allowables with your statistically significant data, and with a stable, repeatable process, you're going to feed that into your analysis methodology. So that'll feed your finite element modeling and the methods that you're going to use to try to characterize the structure. As with a traditional building block approach, you're going to be looking at the coupons and then subcomponent and component level testing, leading to a full-scale test. Those tests should all be done with predictive analysis, and then you're basically, it's analysis supported by tests. So you're ensuring that your analysis methodology is capturing and correctly modeling the characteristics of the material.
When discussing the carbon fiber hull, Boeing stated that this structure will need to be carefully inspected for manufacturing defects such as porosity voids, inclusions, and FOD. Can you explain why this is important?
It'll affect the performance of the product. You'll have reduced capability if you have FOD in the part. One of the primary things is that whatever you cannot inspect, you need to account for in your design. And so your limit load evaluation, when you're calculating your margins, you're going to want to include basically anything, any flaw type or defect in the product that you aren't able to detect.
And how are manufacturing defects such as porosity, voids, inclusions, etc., normally determined?
Well, they'd be determined through there'd be an effects of defect study. So you'd have done a significant amount of testing to characterize what those effects are in the structure. It would be possible you could do analysis. It'd be a higher level of fidelity of analysis, where you're trying to characterize the effects of that.
Could a sample panel from the cutoff ends of a carbon fiber structure be used to make these determinations?
One of the things you'd have to be careful about, you'd have to make sure that you still had, high quality laminates in the edge margin. There's an area of the edge of a part that you would not want to do this. You might be able to get chemical composition data or some characteristics out of that. But if you're going to be doing structural tests, you'd want to make sure that you were away from those edge effects.
We noted that the feasibility study outlined some of the challenges OceanGate was going to face with regards to the design in the report. Could you please summarize some of those challenges identified in the report to OceanGate?
Building a thick cylindrical composite part is a challenge. One of the things you have to worry about is as you lay up the part. What we had proposed was to do a fiber placement system with slit tape composite material. As you build up that component, there's a certain amount of bulk that is generated. It would be, the cured or the as cured thickness, and then the as manufactured or as laid up thickness. The difference between those two is the bulk or, kind of fluff in the material. With the constrained structure and a constrained shape like a cylinder, you need to make sure that you can essentially eliminate that bulk in the laminate prior to cure. If you don't do that, you're going to end up with wrinkles in the final product. One of the other things you have to be really careful about is as you cure those constrained laminates, you develop significant internal residual stress, and you need to model that and you need to characterize that. The other thing you need to be very concerned about is, as you define the thermal and the cure characteristics, you can have exotherms and other problems that are created because you're dealing with a very, very thick laminate. And so, typically we would do a cure characterization where you're modeling the kinetic and the cure performance of the material. With the heat transfer coefficients and pressure and different characteristics of the autoclave that you're curing the part in.
We noted that in the conceptual design report, there should be no impact damage. Can you explain what this means?
Well, the concern would be that that if you're using an unnotched allowable, you're in that feasibility study, we're not accounting for any post degradation of the product. And so that's probably a fine thing to do for a feasibility study, but as you get into a detailed design, you'd be trying to account for those other defects and point loads and other types of considerations in the design. Impact damage might be one of those.
In your experience, is carbon fiber susceptible to impact damage?
The evaluation of impact damage, whether it's BVID, barely visible impact damage, and doing an evaluation of that, or some type of inspected or expected impact damage. Compression after impact is a common test to determine the capability after an impact.
We noted in the conceptual design that it was considered without any thermal residual stress in the laminate. Now, you had just earlier mentioned thermal residual stress. Is this assumption typical when conducting these type of analyses?
Many of these things are dealing with this type or size of structure or the configuration of the structure. We're looking at those with kind of a higher fidelity of evaluation than maybe you would on some other types of components. For the constrained cylindrical structure, you can end up with very high internal residual stresses that create interlaminar tension in the in the, sea level stress state. So a key thing there is that one of the higher stress levels for this type of structure is at the surface.
Would sending a carbon fiber structure into an autoclave over 5 cycles, like it did for the Titan hull, create thermal residual stresses?
Just the act of curing the part creates those thermal residual stresses. The part is expanded, the material system vitrifies or locks in at that expanded shape, and then as it cools down, it creates interlaminar tension or residual stress.
Would these residual stresses be increased the more times it went through the autoclave? So for example, would layer 1 that went through the autoclave 5 times have more residual thermal stress than the other layers?
You'd have to do a detailed evaluation of that. It can depend on how the product heats up in the autoclave, and so the way you've cured it, the expansion of the different pre-cured or green parts, all of those could affect that. So you'd really need to do a detailed model of that.
My next questions will be related to non-destructive testing conducted by Boeing. These questions are not specific to Titan or OceanGate. How does Boeing conduct destructive tests on carbon fiber?
That's kind of a big question. Can you be more specific?
I guess a more general question is, does Boeing conduct destructive tests on carbon fiber ever?
Sure. Yeah.
So for a design, specifically like a new design, would Boeing construct carbon fiber or carbon fiber structure and then take it to failure? Is that a typical mode that Boeing would do?
Yes, I think the key point would be, analysis supported by test. You're calculating your margins based off of maybe a finite element model, but you're using test data to support that finite element and the methodology that you're using is accurate.
Does Boeing conduct non-destructive testing on constructed items out of carbon fiber? Specifically, if there was like a multiple constructions of the same item, would Boeing conduct non-destructive testing only on the first item, or would they do it on all items that are constructed?
This is referring to the multiple cures?
No, this is not specific to Titan. This is just anything that Boeing would construct out of carbon fiber.
We would possibly do a pre-inspection of something, prior to doing a co-bond or a secondary process. If there was something about the process that inhibited us from doing a inspection later on, we might do, pre-inspections of the component to try to characterize that specific component before we added additional material.
If you were to construct the same component multiple times, like you had a series of the same component, would you conduct non-destructive testing only on the first component, and then because you did the non-destructive testing on that first component, you wouldn't do it on the next series of items, or would you do it on all of the constructed items?
So statistical process control in some areas is done when you've stabilized a process. It's typically not done on composite parts. We typically do 100% inspection of all composite parts.
Does Boeing have a rejection rate when it comes to porosity, voids, inclusions, or other potential manufacturing defects?
We do, and it would be material and process specific.
And how are those determined?
Through test.
I'm going to switch to acoustic emission systems. Do you have experience with acoustic emission sensors?
I have general knowledge of acoustic emission.
Have you ever been involved in acoustic emission systems development that uses AE sensors and strain gauges to look at a carbon fiber design?
I have been involved, and I have run programs that use acoustic emission as providing additional analytical data during a composite test. Yes.
Did you have any involvement with the development of the acoustic emission systems for OceanGate?
No, no. Boeing didn't have any involvement. And I believe that system was patented by OceanGate.
Did you have any involvement with the third scale model testing from OceanGate?
Are you talking about the acoustic emission?
Either material testing or the acoustic emission sensors?
We weren't really involved in the materials testing. We saw some things, peripherally saw some of those items. But we did have a small contract. We were requested by OceanGate to bring one of our commercially available acoustic emission systems and put sensors on one of their scaled test articles.
Were you there for the test?
I was not there for that test.
Was any Boeing representative there for the test?
I believe there were two Boeing people there that basically ran the commercially available system to record the acoustic emission data, and then we provided that data to OceanGate.
Were you involved, or was Boeing involved with any of the analysis of that acoustic emissions data from the third scale model testing?
I don't think we provided any analysis. I think we plotted the data and then gave them the download files and the data directly to OceanGate.
Do you believe that using AE sensors is a reliable way to determine the health of a carbon fiber hull?
I think it's a non-trivial problem when you start talking about that. Acoustic emission is capable of providing additional information. How you quantify or characterize that information is non-trivial.
Can you please explain that further?
If you're using it as detection of something is happening, or you're collecting data in a manner that you're going to be able to maybe triangulate a source of, these are basically irreversible effects that create elastic waves. So they're kind of creating this sound. If you're using it to triangulate, if you're using it to understand that something is happening, I think that's a valid use. And I think that's consistent with the industry use of acoustic emission. To characterize it as a no-go-go gauge, that's a non-trivial problem.
Are you aware if Boeing manufactured any components or third scale models for OceanGate?
We did not manufacture any parts for OceanGate.
Are you aware if Boeing helped or gave advice to OceanGate about the type of carbon fiber to purchase?
I don't believe we would have described what to purchase for OceanGate. I don't think we ever saw a final design or analysis from OceanGate.
And why did OceanGate and Boeing stop working together?
We had a number of different requests from OceanGate to respond to different requests for proposal. I don't know exactly, I think maybe we were too expensive.
And what time frame was OceanGate and Boeing working together?
We had two different periods. The first was in the 2012-2013 period where we did the brief feasibility study. And then in 2016 was when we did we supported two different tests to record acoustic emission data.
And from your knowledge, is that when OceanGate and Boeing stopped working together in 2016?
I think the last time Boeing was in discussion with OceanGate was March of 2020, where we declined to respond to a request for proposal.
Thank you. That concludes my questions.
Lieutenant Commander Emmons now has questions for you.
Good morning, Mr. Negley. I just have a few follow-up questions. You had mentioned CAT scanning and X-rays as non-destructive testing. What can you detect in a carbon fiber hull with those tests?
Well, if you're able to do a detailed CAT scan, you can get down to the individual fiber level. On this size of part, you would have reduced capability. You might be able to see something you might be able to see something related to a disc bond if it was significant, and you might be able to see, some type of waviness in the fiber on this scale of component.
And can you physically see those items you just mentioned within the hull without non-destructive testing or CAT scans?
You might have indications on the surface, but without that, you probably would not see that. There are some techniques through ultrasonic inspections where you can generate data related to wrinkles in composites, but it's very limited in terms of thickness.
Since you mentioned wrinkles, what are some of the ways you can eliminate wrinkles in the final laminate product?
With this type of component, with a constrained construction, you really have to lay down the material with zero bulk. So there needs to be no difference between the green product and the cured product. If you can do that, then you should not have wrinkles in your part.
And if you did have wrinkles in the final product, have you ever seen or would you recommend sanding down wrinkles to smooth out the layer for the next layer?
So we have done on the Deep Glider program, we did some multiple cured parts, and we have and did have wrinkles, very minor wrinkles, in some of those components. I believe, if I remember right, that part has about 160 plies in it. And I think we may have had a wrinkle that was about 3 plies thick, maybe 4 plies thick. And, we would have looked at that, we would have characterized it, and then we would have done an analysis of the reduced performance, and really kind of looking at what the effect was of that wrinkle or the what we were doing to deal with that wrinkle. The reason on a multi-cure construction that we might sand that down is we don't want that wrinkle to propagate into the outer layers. And so there's a risk assessment that needs to be done with that, and there's an engineering analysis that needs to be done to make sure that the component still meets the capability as designed.
And to your knowledge, in working with Boeing, are there any regulations or policy regarding experimental aircraft and paying passengers?
That would be outside of my expertise.
Understood. Thank you.
Sir, at this time, I'd like to go to the National Transportation Safety Board for questions. Mr. Muse?
Thank you for your testimony, Mr. Negley. I have no questions, Mr. Chair.
Mr. Negley, I do have a follow-up from what I believe you said earlier, that one of the higher stress levels for a carbon fiber structure such as Titan would be at the surface. Is that correct?
That's correct.
And just to understand that further, is that because the stresses experienced at depth would be maintained as the vessel ascended? Is that a correct interpretation?
This is from the, as the part is cured, it's vitrified, or it locks in, its stress-free temperature is close to the curing temperature. And so as that cools down, it develops interlaminar tension within the laminate because it's a constrained structure.
Thank you. Just want to make sure I understood that correctly. Lieutenant Commander Williams has some additional questions, sir.
Is there an engineering recommendation for storage of a carbon fiber cylindrical hull critical to hull integrity in terms of temperatures or humidity?
Temperatures or humidity. I would think on a critical structure like this, you would want to maintain control of it. Room temperature ambient. I don't know that there would be, I could answer in terms of like a requirement, but you would want to evaluate, it would be a design requirement, and you would have to evaluate it in your design in terms of what the storage temperatures were going to be.
In your experience, would cold temperatures affect carbon fiber?
Well, certainly could. The delta between that stress-free state and the temperature that it receives would increase the interlaminar tension on that hull. You'd have to evaluate for those environmental characteristics. The other thing that you could have is if it had a cold soak and then you heated the outer structure, that might exacerbate that.
For testing purposes, should third scale models be constructed in the same manner as the full scale model?
If you're going to use it to support your analysis, 100%.
And why is this?
You're trying to make sure that your engineering analysis is accurate. And so you'd want it to be representative of the material and the process that was used to manufacture the part.
Thank you. That concludes my questions.
I'd like to go to OceanGate for any questions at this time.
No questions, thank you.
Are there any further questions from the board for Mr. Negley at this time? All right, I see none, sir. Want to say thank you for your time today and your testimony to the board. You are now released as a witness to this Marine Board investigation.
So that concludes the testimony of Mark Negley. As with the last testimony, with a representative from NASA, it was interesting to finally hear from someone outside of OceanGate, who was present at the time, to speak about and clarify the amount of involvement their company actually had with OceanGate. And it was confirmed that the first instance was in 2012/13, where the feasibility study was done by Boeing for a composite hull. The second instance was in 2016, when, as well as providing equipment, Boeing also sent personnel to help record acoustic data during OceanGate's scale model testing. It stated that the feasibility study came up with a concept that a 7-inch hull could be feasible, but did not take into account possible defects or considerations of other parts of the overall design. As we have heard in the past, at one point there was talk of a 10-inch hull, and even with that 7-inch possibility, to account for those other variables mentioned, Mr. Negley said that this meant it would have been expected that the hull got thicker. The use of 45-degree plies was also brought up, a subject which was in Roy Thomas's presentation. It stated here that the production method proposed by Boeing did not allow for any configuration that did not include 45-degree plies. Mr. Negley also states that Boeing never saw a design or any analysis from OceanGate when their design choice deviated from this. Also covered were some non-destructive testing methods, and when asked if they would be successful through 5 inches of carbon fibre, Mr. Negley says that Boeing have demonstrated it possible through transmission inspections at 12 inches. As with any of these testimonies provided by experts in the field, I myself am no expert at all, and through transmission inspections is not a phrase I can recall hearing before, but I did find this explanation online, and hope that it correlates with what Mr. Negley was speaking about. Also, I just wanted to include it to show that there were perhaps avenues OceanGate could have gone down in terms of non-destructive testing. I believe it was stated, perhaps in Tony Nissen's testimony, that there was an attempt at NDT testing when OceanGate were in the Bahamas, which was ultimately unsuccessful. We also heard about the importance of inspections after any impact damage, and then about the process of sanding away any imperfections or wrinkles. Mr. Negley explains that a risk assessment and engineering analysis should be done afterwards, as just as we heard in, once again I believe to be Roy Thomas's testimony, you are basically removing part of the structure when you do that, and so don't have the strength of those full plies, and knowing how that could affect integrity and safety should be paramount. Regardless, once again it was good to learn more about the interactions between OceanGate and Boeing, as we've spoken about before, and heard about from people such as Patrick Leahy. Real-time monitoring shouldn't be necessary if your hull is a safe one, but it certainly can prove useful in testing, for example. Even in the case of the shift in strain data that occurred on Dive 80, this should have been a moment where operations were halted and due care taken. As well as the audio events of the hull, either in testing or when operating the full-scale hull, all third-scale models had failed, as well as Titan's first hull. and as Bart Kemper spoke about in the testimony previous to this one, it doesn't seem like OceanGate did enough, due in part I'm sure to the need to get Titan diving as soon as possible, to actually know what safe meant. Anyway, thank you all very much for watching, it is greatly appreciated, and I'm looking forward to sharing the last few testimonies with you all, and to hear from members of the US Coast Guard, as well as another ex-OceanGate employee. But for now, that concludes the testimony of Mark Negley, and I hope you found it insightful. So until our next video, bye for now.